thank you guys for coming out. Yell at me if you can't hear me. If I get too quiet, I'm sorry I have to sit down. So this talk is about StatsD. Hello. My name's Garann Means. I'm an Austinite. You can find me on Twitter or on the web, Garann on Twitter, or Garann.com on the web. That's from last year, International Programming Day. I hope that you all participated. And that's how I'd like you to think of me, even though I didn't dress up for tonight. So I work at StatsD, which we'll discuss in more detail if you're not familiar with. I'm on the front-end and performance team. We do front-end performance. And so a little bit about StatsD in case you're not familiar. This is our site. You may have seen it if you have ever looked for crafts, vintage stuff, whatever. What we basically are is we're a platform for selling handmade and vintage goods and also supplies for making those things. It gets a little crazy. We have zillions of users, tons and tons of listings. Like the numbers are very large. I didn't get them because they change all the time. But we have a lot of users. So if you haven't heard of us, that might be because you're not part of the group of people that we serve. But it's a big site basically. It's worldwide, and there's a lot of money that goes through StatsD. As far as retailers, if we were a traditional retailer, we would be just under Hot Topic, and we're kind of gunning for Hot Topic right now. And I hope that you'll support us in that. The bottom line with StatsD is kind of that people make their livings on this site, using the site. So we try not to have the site go down because there are a lot of people who stay home and make crafts, or like they go and like find vintage stuff and like whatever, and they sell it. And that's actually how they make their livings. So we try to keep the site up as much as possible, obviously, like everybody else does. But if the site goes down for us, it doesn't really affect our bottom line so much because like I said, we have like a lot of users, but it affects these individuals, which we don't want. So that makes StatsD a very ops-focused organization. We do pretty much everything automatically. We automate our testing, we automate deployment. That's not this talk, but if you were interested in looking into how we do things a little bit more, there's something called Deploymid, which is a really cool tool that just, you push a button and your shit goes to production. We A/B test everything that we do. Pretty much, I pretty much mean everything. Like if something goes into production, if it's a feature, if it's a performance improvement, anything, we're usually A/B testing it. We're going to check to see how it compares with what we're doing right now, and that will come up later. So we have lots and lots of metrics, and we're probably, as an engineering organization, if we're known for anything, we're known for our tools. One of those tools is StatsD. StatsD is open source. You can grab it off GitHub. This is its attractive GitHub page that looks like many other GitHub pages you might have seen. And it's a tool basically for collecting UDP requests. And what you do is you have a bucket. You define a bucket, which is just a key that you're giving to whatever you want to collect. And you don't have to define those beforehand. You define them as you need them. And StatsD will sample that data for you. And then periodically that will get flushed to some sort of backend. The most common one that you would you probably have seen if you looked at our examples or a lot of the people who are using StatsD is Graphite, but there are other options as well. So I don't know if you guys can see this code. The bottom line, you can't see that code, I know because I've sat in the back, is that this is very, very simple stuff. What we're doing basically is we're looking at a string, we're checking whether it has a certain prefix, and we're going from there, we're distributing it into one of these buckets, and that's pretty much it. It's, I think, 400 lines of code, the entire program. So there are a few different things that it will collect. The easiest one is a counter. So you're just going to send a count of whatever it is. Like 1 second you send 496, the second you send 347, etc. Those are counters. It's easy. You're sending integers basically. Timers are like a little bit more complex, and something more complex that we will discuss in a minute will happen. But they're what they sound like. It's how long something took. A gauge is a sort of tricky wording kind of thing. A gauge just means it's something that's fixed. So like you're not expecting it to change as often. You want to compare it to other data and keep track of how something perhaps changed less over time. And like look at your counters or your timers in comparison to that. So the timers are the really interesting ones, and this kind of reveals what the goals of StatsD were when it was originally developed. The client is going to be responsible for measuring how long something took to happen, and you're going to, like, you effectively have a timer. You send that information to StatsD, and then StatsD is going to split that out into a variety of pieces of information based on the timers it's collected, the timers it's been sent before it flushes again to the back end. So the 90th percentile, the average, the upper and lower bounds, and then all of that gets flushed out to whatever back end you're using. Another one of the less immediately understandable features is sampling. So you obviously have things on your website that are going to happen all the time. They're going to be happening constantly. You don't want to continually be sending requests to StatsD because you have more important things for your servers to be doing. You don't need that much sampling. So you only record every nth event. And so if you say that you're only recording like 1/10 of these events or whatever, StatsD will take that and it will extrapolate based on what you've sent it, what should be in between. It kind of tweens your data. And so statistically it's correct. Obviously if there was like some crazy spike that happened that you were not recording, that wouldn't get recorded and you would completely miss that. But on the other hand, it doesn't script your axes so that you can, you're still looking at things as though you're looking at whatever happened every second, or whatever the axes that you're using are. You can not have to change the span of time that you're looking at. So what that comes out to, in the end, is you get graphs like this, which are not super exciting in and of themselves, but when you think about what they represent, can be very, very useful. So, using StatsD. Assuming that we're JavaScript developers here and we're using Node on the back end, which may be a stretch, but there are clients for Python, PHP, Java, pretty much everything else as well. But these are the Node clients, which I think are interesting to look at. So there's two. There's Node StatsD, which has it has more watchers and it has more features. And then there's Node.js StatsD client, which only has a few users but was the more recently updated. There is no Node example in the project itself. Because these two already exist, we probably won't be adding one. So if you were going to use something to work with Node as a client, I would probably recommend the top one right here, the Node StatsD. So this is, oh you guys can see that either. The way that you use a client is super simple. You have an npm module, and you import that into whatever you're using. And I think they both have actually exactly the same API. So if you're using one of these two clients, you won't have very much work to do if you want to switch back and forth for whatever reason. So the examples that this one is showing is increment, and it's passing in a key, which is the bucket, and decrement, which does the opposite of increment. And then there's a timer that it's passing in. So it's passing in the name of a bucket, which is namespaced in this case, and it's passing in 500 milliseconds. So it's pretty straightforward. And if you were using the same client, you could also, it's not documented very well, but the code, again, is so small that you can just read through it and pretty much figure out how to use it. You can pass in addition to the bucket that you're using, in this case, the number of milliseconds, and you can pass in a sample rate, which is what we were discussing earlier. So if you want to only look at 1/10 of the events that happen, you can pass that in as well. So there's a bit of an expanded API for this if you look at the code. But really, like, this is incredibly simple. That's the bottom. So if you wanted to do it yourself, the second library we're looking at, where is that? Oops. Node.js StatsD-client actually provides a really good example of how you would do this yourself, because it's not trying to do everything that StatsD does. So this is all you would, literally, all you would need to do if you want to set up StatsD on Node. You create a Garann socket here, which is going to allow you to do UDP. And once you've created that, you start creating buckets. And having those buckets, you send data to them. Or you send the buckets with the data. And that's basically it. You're just making requests. You're making UDP requests, and StatsD will receive all those. So just to be completely clear, StatsD and Graphite are not related. So StatsD is just the very simple Node application that receives all this data, and then you plug in a backend to it. And backend is a bit of a misnomer, I think, because they're actually front ends. The part of the backend that we're looking at is the front end. It's visual. They're HTML pages. And you're gonna have a module in StatsD that will listen for the flush event, and then we'll actually flush to these backends. And the backend can be anything. The only ones you get with StatsD when you first download it are Graphite and Console. Graphite is a little bit wordy, so I was going to try to show you Console. Basically, all that's happening here is you have two event handlers, and the big one is flush. So when the flush happens, you take your keys and you spit them out, essentially. This is a lot cooler in Graphite, but you would have been able to see it even less, so that's why we're not looking at it. But what happens in Graphite is that, like StatsD, you don't do any setup beforehand, so you don't need to tell it what the buckets or keys that you're going to be using are. You just create them, and then those keys in turn become files when you flush them out. Files will actually get written, and that's essentially your database. And then you get real-time updates from those files within the Graphite UI. It's pretty simple. It doesn't mean that it's the best, but it is the one we use at Etsy, and it's the one that it comes with a module for working with. So the bigger picture of StatsD and Graphite is our continuous deployment system. Why we created StatsD is basically support for continuous deployment, which is kind of a religion of Etsy. I don't know. This is our blog, Code is Craft, and my coworker Ian Malpass, Indic, he has this quote from this blog post: "Measure anything, measure everything." We found that tracking everything is key to moving fast, but the only way to do it is to make tracking everything easy. Using StatsD, we enable engineers to track what they need to track at the drop of a hat without requiring time-sucking configurations or complicated processes. So what that basically means is we just test the shit out of everything. We put StatsD on everything so that we can always see everything on a graph, and we'll know if something starts failing or if it starts succeeding wildly, which is awesome. But because we're constantly deploying, we want to be able to have something automated, keeping us in check. So the culture at Etsy that causes us to need something like StatsD is, again, obsessive A/B testing. Like literally everything that you ever see on Etsy, if you use Etsy, has been A/B tested. Everything has been compared against whatever was there before, and potentially like some other version of itself at the same time. We don't QA things. We don't have a formal QA. Engineers do their own QA. So we're responsible for testing, and our production is essentially our staging. Like the A/B tests, the flags that we use, essentially put something into the equivalent of staging. Like staging happens on production. We test things in staging on production by putting them behind config flags rather than having a separate server and a separate environment. So we're using real data, and we're using real users and like real people's livelihoods. So like the A/B testing is a big thing, and we take it very seriously, which is why we have graphs telling us how we're doing. And of course, continuous deployment. We deploy as many times as we possibly can during the day. Like people will be hitting the deploy button, which is literally a button, all throughout the day. And I don't know what I think the record was something in the 60s, but I'm not, don't quote me on that because I can't remember right now. But it's a lot. We do a lot of deployments a day. And so we need to be able to quickly see what the results of those are, and more importantly, see if we've broke anything. So again, that's where these graphs come in. So these, I don't know if you can read the headings, but they're business information, registrations, logins, checkouts, things like that. So if we see one of these dip or even move around a little bit, we know that something's happened, and these graphs are like our first indication. As soon as we hit that deploy button, something's gone wrong, and we have completely effed up the site for all these people who, again, whose livelihoods rely on it. So this is StatsD seems like it's a very small tool, but it's a very big part of what we do as a business. So continuing on with that. Things that we get out of StatsD are obviously, is anything broken? But also, we can, over time, also see whether usability has improved, like, which is, of course, what we want. We want to find places where we can improve that we haven't necessarily touched recently. See whether we can speed up the performance. And of course, what's just being ignored. If we work on something and it's not received as well as we'd like, we want to know that as well. And then over time, we get some of this from StatsD. We have regular logging as well. But we want to know, of course, if things are slowing down, potentially because of memory leaks or whatever. Edge case errors, like people wandering into weird parts of the site and doing weird things, or like having weird account settings, whatever, and code decaying, which is memory leaks, right? But StatsD can still tell us these things potentially before our logs might, or like other types of analytics might, just because it is so immediate and we are getting it all the time. There are some side effects though. When it comes to the actual code that we're writing. Of course, the real testing happens at the last minute. Like, you can test on your own dev machine, but that's not always going to be the same as testing in production/staging. And when production/staging are actually the same thing, it means that you don't find out until the very last minute if something's gone wrong, which is not usually a big risk, but for certain things. It means that there's a lot of branching logic in the code to test multiple versions of things. So if you have an A and a B, that means you have to have logic, you have to have an if, and you have to have duplicate code probably in most cases. On the other hand, it means that we can triage our failures very quickly because we see them immediately and visually, and everybody sees them. And it means that rollbacks can be almost instant because we take an A/B approach and we can just shut off B if B is failing. So, when I started at Etsy, what I wanted to know about was Node, because this is one of Etsy's few Node projects. And how this is working in Node. So honestly, we currently have some issues with Node. And we are in the process of checking out whether we have the muscle with Node, with the machines we currently have, to actually test everything, because we are, again, literally testing everything. And it's interesting, for me, if I take a step back, as somebody who wants to use Node, to note that this hasn't translated at all to Node in production. Node is still, at Etsy, still stuck in the world of DevOps. It's not something we use on the actual site. So I hope that will change, but for right now, that's sort of the result. So looking toward the future of StatsD, we have a number of open pull requests and issues on our GitHub repo. People want more backends, And we've recently changed to use event emitter instead of what we were doing before, which was just like writing it all online. So now these are a little bit more pluggable. Like you just have to handle an event, and you can have the kind of backend you want. So that's a cool advantage. I think that we have a lot of backends already, though. And interestingly, a lot of people have written their own internal custom backends. There are a lot of companies using StatsD internally who've written their own tools for displaying. People want more types of information to collect beyond just counters and timers and pages. People want more client examples, and unfortunately, I think that we're going to have fewer client examples going forward because, again, people have written those. They're already their own GitHub projects, and they already exist in other places. And people want to change the prefixes or just get rid of them entirely. What we're working on is allowing Node to, or allowing StatsD to scale up within Node to use multiple servers, trying to split out the event listers from the aggregation so that we can hopefully make the scaling up easier. And then we're, to do those things and to make sure that we're doing them correctly, we're using StatsD for StatsD. And hopefully that will improve the project, which continues to kind of truck on by itself. So that's basically what I would say.